class. Today we are on lesson 94 of course 3, and the title of this lesson is Graphing Pairs of Inequalities on a Number Line. So I want to start out with a review of what is an inequality. Well, an inequality is any kind of expression that uses these symbols, whether it's just the less than or the greater than symbol, or the less than and equal to and the greater than and equal to symbol. So here's an example of an inequality which actually has two values that it's comparing to h. So this is called a pair of inequalities, and it's written as kind of one expression right here, but we can break it down into two separate expressions just comparing it to h. Since 65 is less than or equal to h, if I were to put h on this side, would I say h is less than or equal to 65, or would I flip the equation? If we're going to talk about alligator mouths, notice that the alligator here is trying to eat the h, so we need to keep it facing the h there when we flip the equation like that, or expression. So h is greater than or equal to 65. We took care of this part. Now h is also less than or equal to 90. So basically we have some constraints for h. We know that h is going to be somewhere in between 65 and 90, because it's greater than or equal to 65 and it's less than or equal to 90. So we're going to graph this on a number line. If I were to graph h is greater than or equal to 65, I'd put 65 on my number line here, and I'm going to give it a closed dot because of the equal sign. And actually, let's do this in a different color so we can see it a little better. So, there's my h. Could be equal to 65, or it could be anything greater than 65. So, this number line represents this inequality. We're going to make another number line that represents our second inequality here. H is less than or equal to 90, so we'll put 90 over here. And it's a closed dot because of the equal sign. And then my arrow goes that way, less than. Okay? So what we need to do in order to graph this one is basically combine the information from both of these number lines. So I've got one number line here. It's going to go from 65 to 90. And I know because of this inequality that my h value cannot be less than 65. I know because of this inequality that my h value cannot be more than 90, but anything in between is fair game. So, can you tell me why I have closed dots on my number line here?
You would have closed dots because it is equal to 65 and 90. It could be.
It could possibly be equal to 65. It could possibly be equal to 90. And this would be the final answer for how to graph this pair of inequalities on a number line. Okay, let's move on to example 1. It says, use a number line graph and an inequality expression to describe the statement. Now this is written with words. The length of one side, which they're calling S, of a triangle is greater than 2 and less than 8. So the length of one side is greater than this. I'm going to use my greater than symbol, is greater than 2, and the length of one side is less than 8. So I wrote it like that. you could have also done this to put it in order from smallest to largest. Either way, we've got the same amount of information to be able to put that on a number line. I'm going to have 2 all the way to 8. Now, it said nothing about it being equal. So am I going to have a closed dot or an open dot?
An open dot.
I'm going to have an open dot on both of them. And I know that my S has to fall somewhere in between 2 and 8. So if I graph that, every value in between 2 and 8 is a possible answer for S. Example number 2. Graph the solution set of the inequality, and it gives us the inequality here. -1 is less than or equal to x, which is less than 5. And it wants us to graph the solution set. The language changed because our previous problems said nothing about a solution set, but the task hasn't changed whatsoever. Graphing the solution set is the same thing that we've just done twice before. So, I have my number line. We're going to go from -1, and I'm going to put a 0 in here just because if we have the negatives to the positives, I like to point out where 0 is. All the way up to 5. And x is going to be greater than, because my alligator's facing my x, greater than or equal to -1. So on my -1 here, should I have an open dot or a closed dot?
Closed dot.
It should be closed because of that equal sign. And my x is going this way. It's bigger than that. X is less than 5. Should this be an open dot or a closed dot?
An open dot.
That one should be an open dot. And then in between, I've got x can be anywhere in between those two values. Example 3. Graph this pair of inequalities. So here they wrote it a little differently. They're saying t is less than 40 or t is greater than 100. Okay, so this one's a little bit different because t is less than 40 or bigger than 100. That means t can't be 50 because 50 is not less than 40 and it's not bigger than 100. So on this number line, we're gonna, wow, excuse my squiggly line here. Let's see if I can straighten it. Not much. Okay. So on this number line, we're gonna have our 40. We're gonna have our 100. And will my dot on my 40 be an open dot or a closed dot?
Open dot.
It's gonna be an open dot because we don't have an equal to. And we're saying that t is less than 40. On the number line, less than goes that way. So I'm gonna have my arrow go that way down the number line. Here, t is greater than 100. Open dot or closed dot?
Open dot.
Open dot. And it's greater than, which means my arrow's gonna go this way. So basically in this type of problem, we're saying t is any possible number except it is not between 40 and 100. Because these arrows go on forever and ever all the way into the negative numbers down that way. This arrow goes on forever and ever up to the millions, billions, trillions this way. But t does not fall in between 40 and 100. All right, that is the last example. I'm going to put a couple of the practice set problems on the board for you to try at home. Once I have them up here, if you would like to pause the video and work on them, then hit play and we'll go over the solutions together. So problem A is -3 is less than x which is less than 3. That's problem A here. Problem B. X is less than or equal to negative 3, or X is greater than or equal to 3. Problem C. 5 is less than X, which is less than or equal to 10. And problem D. X is less than 0, or X is greater than or equal to 5. Okay? Try those problems on your own, pause the video, and we're going to go over the answers next. So, for problem A, we want to have our number line. What numbers am I going to label on the number line, Kalan?
Negative 3 and 3.
I'm going to label negative 3. I'm going to label 3. And should negative 3 be an open dot or closed dot?
Open dot.
You know what? Let's do this different color again. Open dot on negative 3. What about positive 3?
Also open dot.
Also an open dot. And is X in between those values, meaning X is bigger than negative 3 but smaller than 3?
Yes.
Yes, it is. So we'll fill in the in-between there. That's the answer to A. Problem B. Once again, we're going to have our number line. What numbers would you label here, Kalan?
Also negative 3 and 3.
Also negative 3 and 3. Looks very similar to this one. Is negative 3 going to be an open dot or a closed dot?
A closed dot.
It's a closed dot because of the equal sign. What about positive 3?
Also closed dot.
Also a closed dot, equal sign. Now we're saying X is less than or equal to negative 3. So what direction should my arrow go?
To the left.
To the left. Or X is greater than or equal to positive 3.
So it would go to the right.
So this one goes to the right. Okay? Similar number lines, different answers. Take a look down at problem C. We've got 5 is less than X, which is less than or equal to 10. So what numbers should I label in my number line?
5 and 10.
5, 10. Open dot or closed dot?
Open dot.
Open dot on 5. Open dot or closed dot for 10?
Closed.
Closed dot on 10. X is going to be greater than 5. So we go this way, right? But less than 10. So this is another example of the value to the solution set being in between our two numbers here. And problem D. Here's my number line. Kalan, what value should I label on my number line?
0 and 5.
0, 5. Is 0 an open dot or a closed dot?
Open dot.
And 5?
Closed.
Closed dot. No equal sign, open dot, equal sign, closed dot. Now, X is less than 0, so what way do I go, left or right?
Left.
Left. Or X is greater than or equal to 5,
Which would be right.
which would be right. So I do want to point something out in the problem here. Notice that if the solution is in between the two values, it's written like this as one big pair of inequalities, versus when the solution goes to the outside of the number line, it's written like this, because you can't put X in the middle of this type of problem. It wouldn't work. Okay, so that's a little trick that you can notice and go, oh, I know my solution's going to go that way, or when you see this, my solution's going to be in between the two values. Okay, there is one more example, which is a word problem, so I don't want to write it up on the board, but I will read it to you, and we'll look at it together. Okay. A college will cancel a lab class if less than 12 students enroll. No more than 30 students can enroll in one lab class. Write an inequality that shows the number of students, and they tell you that your variable should be S, that could be in a lab class, and illustrate this inequality on a number line. So we're going to start with S for students, and it says that the number of students must be greater than 12, because if the number of students is less than 12, they'll cancel the class. So the number of students has to be greater than, that's why I have the alligator facing them, even though the symbol really means less than 12. And they can't hold any more than 30 students. So the number of students has to be less than 30. Now we have to decide, should we put an equal sign here or not? So a college will cancel a lab class if less than 12 students enroll. Does that mean it's okay to have just 12 students?
Yes.
Yes, so we're going to have less than or equal to, because 12 students are okay, 11 students aren't. Now we'll read this one. No more than 30 students can enroll. So is 30 okay as an answer? Yes, it is, so we'll have an equal sign. So here's our inequality. The second part of that wanted us to show this on a number line, so I'm going to have you do that problem.
So 12 needs to be less than, so you'd put 12 and a closed dot because it is also equal to, and then an arrow going this way.
Wait, 12 is less than S. Is 11 okay as a solution?
Oops, no.
Nope,
Oh, my-
that's okay.
Okay, needs to be that way.
Yeah, here, you want to do it with the purple one?
Thank you. And then 30 needs to be less than 30, so we put 30 here with a closed dot because it could be equal to 30, but it needs to be less than, so we go this way.
Okay.
So anything in here would be okay.
Anything in there would be okay. So should you have these arrows here going past your two dots?
No, it would make a segment with the two closed dots.
Right, so we're only looking at the values in between 12 and 30. So in your final answer, your line will stop here at 30 and stop there at 12.
Mm-hmm.
You got it. All right, if you have Saxon Course 3 at home, now is the time that you should start your written practice for lesson 94. It begins on page 631. I hope you have a wonderful afternoon, and we'll see you again soon.